for a decent grade. As far as the y-intercept goes, okay, the y-intercept is negative 55.8. That's fine, but why not throw on what it actually represents? Negative 55.8 yards. Now sometimes the y-intercepts won't make any sense. This would be if the golf club was traveling at 0 miles per hour. It says that the golf ball would actually go backwards. So not exactly true, and that's kind of going on to the idea that the line of best fit's trying to explain the data mostly in the domain that you're given. I mean, if the farther and farther you creep out of the domain of the given x's, the less accurate or reliable the information could be. As far as the predicted distance for 103 miles per hour, you can plug in 103 miles per hour in for x to figure out what the distance is, which is y. A nice way to use the calculator to help us out here is to use the graphing calculator to post the graph. So to do that, you can go to y equals. You could type in the equation. You could type in 3.166x minus 55.8, just like that. If you want to get a more accurate answer, you can use the calculator to do that. You can press the VARS button, and then go down to choice 5, statistics, and then go to EQ, and look at the first choice, regression equation. If you type that in, it dumps in a very complete equation, and then by pressing graph, you can see the line of best fit, and that it's doing a pretty decent job of explaining the scatter plot. From here, we can use the command second trace to get us to the calculate menu. And the first choice there, so second trace brings me there. The first choice there is value. If you click that choice, you can type in the 103 miles per hour that we're interested in, and you can see that at the very bottom of the screen that it's predicting that the golf ball will travel about 270.3 yards. All right, so last is to show you about the residuals. If you're asked to calculate a residual, residual is the actual minus the predicted, and convenient for people taking AP stats, AP can be easily, you can easily remember. So the distance, you'd have to go all the way back to the beginning. 274 was the actual distance that golf ball traveled. The predicted distance we just found out was 270.3. You subtract the two, you get a residual that's positive, and it's at positive 3.7. A positive residual means that we underestimated. A positive residual means that the actual was greater than the predicted. And sometimes it's hard for students to remember, you know, does it overpredict or underpredict when the residual is positive? It's the opposite of what you think if you're thinking along those kinds of lines. If the residual is positive, it means that the prediction was under the actual value. So you see how that's different. Positive means under-predicting. Negative residual means over-predicting. And that seems a bit backwards. But if you look at it if you look at it from another angle, a positive residual means that the actual was greater than the predicted. If you're ever in doubt of which is which, you can take a look at the graph and see, does the line go below the actual point or above it? Another thing you can do is just fall back on this formula, the actual minus the predicted, and then make the judgment there. Okay, the predicted is definitely less than the actual. One more thing I can show you is the residual plot, which is an important way to judge whether or not the line of best fit was successful. And the residual plot is another version of the scatter plot that actually straightens that scatter plot out, flattens it out, turns it horizontally, and it accentuates, or I don't want to say exaggerates, but it emphasizes how the points compare to the line in terms of are they above or below what was predicted. And you can kind of see what's happening by just looking at the scatter plot, that the line is doing a pretty decent job of modeling what's happening there. But in other cases, you're going to want to take a look at the residual plot and look for information that might make you believe that you can do better. And the way to get the scatter plot turned into a residual scatter plot is by going to second y equals and changing the y list into the residual. And to do that, you press second stat. So second stat will bring you to the list menu. And you can see it in some calculators it's listed as number 7, some 8. The residual is right there. Zoom 9 again will give you the scatter plot. Now it's a residual plot. The horizontal line represents the least squares regression line. And you can see that we've got, 1, 2, 3, 4, 5 points above, 3 points below. These two are really close. The low one and the high one of the high ones there. You can see that in general that line of best fit, which is now horizontal, does a good job of under-predicting and over-predicting, but not more one so than the other. If we had a residual plot that had a curved pattern, like a smiley face, or a sad face, or some sort of S pattern like that, that would lead us to believe in the line. Even if our R squared was really good and really impressive, here the R squared was 88%. That's pretty decent. As it turns out, that might be the best we can do. There'll be other instances where you might have an R squared that's over 90% successful, maybe even over 95% successful, and yet the line still might not be the best tool to predict what's happening. And that's, you're going to have to fall back and do some other kind of regression. And that's coming up in another chapter, and hey, maybe another video. So I don't think I did it in under 10 minutes, but there's a quick explanation of how it goes, and I hope it helps. So stay tuned for more videos, and you can always request videos too. I'm open for requests at any time.